Okay, in this video I'm just going to give you a brief overview of what maximum and minimum values of a function are. And to understand that, we need to think about a couple of different things. One is what are called absolute extrema. So you have an absolute maximum or an absolute minimum if that y value is the largest y value for over the entire domain of f. And then an absolute minimum if the y value is the absolute smallest y value over that entire domain. Okay, so sometimes we're going to restrict the domain to where we'll just look over a specific interval, and we would look for what is the biggest y value on that interval and the smallest y value on that interval, and that would give us the absolute extrema. Local extrema are they occur whenever we have basically a hill or a valley right here. So you're looking at over a very small interval. What is the highest y value there, or what is the lowest y value there? So what you're looking for are those places where you would have horizontal tangents, which would occur here and also up here. So and a quick example here is if I looked over the interval from A to E, which is all that I see this graphed on. Okay, so for all I know, the entire domain of this function is just from A to E. But if I wanted to know what is the absolute max over that interval, well, that occurs at D, right? So the absolute max happens at D. So I don't know what that value is, but I know that it occurs at D. And then the absolute minimum, that would happen at A. That's the very smallest y value, so that happens at A. And then local max, we have two of them. There's a local max at B and at D. So an absolute max could also be the local max. So we have these at B and at D. And then we have a local minimum at C. Now, there's not a local minimum at A because I don't have that valley there, right? So, and then the same is true about E. I don't want to just say, well, this is some kind of maximum or minimum or something like that. That's not true. So, this is a good example to show that an absolute max could also be a local max or min, but it doesn't have to be. So the minimums here, the absolute minimum was not also a local minimum. Okay, so here's an example of an actual function, which I have graphed for you. This is the function that's given here. And it's graphed if we're looking over the interval from -1 to 4. -1 to 4. Use the graph to find the absolute maximum, absolute minimum, and any local max or mins. So, absolute max. If I look at that graph over the interval from -1 to 4, what is the very highest y value that we achieve? And that occurs over here at -1. That's up here. Now, ideally, I would like to know what the y value is there. So, you know, if I know the absolute max is at -1, I could plug that in to this function to give me that y value. Don't just estimate by what it is here on the graph. Okay, so if we actually plugged in -1, we could do that really quickly. That would be 3 plus 16 and then plus 18. So that's going to be an absolute max at 37. Right, so -1, 37 is where we have our absolute max. The absolute minimum over that interval from -1 to 4 occurs at 3. Right, that's where we have the very smallest y value. So that's going to occur at 3. And again, if we plug that in, I'm going to use Desmos to help me out with that one. We have 3 times 3 to the 4th minus 16 times 3 to the third, and plus 18 times 3 squared. So that's at negative 27. Okay, so that's absolute. And then local, where we have local extrema. So we'll start with local maximums. That would occur here at 1. The y value there would be 5. And that's the only one that I have. I don't have any other of those peaks. Local minimum should be a couple. 1, we already know this is going to be 1 over here at 3, so 3 negative 27, but also we have one here at 0, 0. Okay, so that's just a brief overview of the definitions of absolute and local extrema. In the next videos, we'll go through how to find those if I don't have the graph.